Everyone, for today's lesson, we are going to learn about direct variation. This is the beginning of our rational functions unit, and it is a trip down memory lane where we are going to be connecting linear functions to eventually rational functions. Before we get started, I would like you guys to please complete the following warm-up, in which I would like you to please write an equation of a line. Now remember that an equation of a line is y equals mx plus b. And I'm giving you two sets of ordered pairs. Now remember that in order for you to write an equation of a line, you need to identify what the slope is and the y-intercept. So I'm going to remind you of what those things are. Remember that to find the slope between 2 points, we use the formula y2 minus y1 divided by x2 minus x1. And that's because slope represents the change in y divided by the change in x. The other thing I want to remind you of is y-intercept. And our y-intercept is always the b value. More specifically, it's located at the ordered pair 0, b. So it's where x is equal to 0 and where y is equal to a specific number. And that's our location of the y-intercept. So now that we've kind of reviewed a little bit of Algebra 1, I would like you to please go ahead and pause the video and complete this warm-up on your own. When you have an answer, please restart the video and we will see how well you did. All right, let's go ahead and see how well you did. So first thing we want to do is identify our slope. So our slope in this problem, we're going to take the change in y over the change in x. So I'm going to subtract 3 minus 0 over 2 minus 0. Change in y over the change in x. And by doing that, we end up with 3 over 2, which is our slope. Our b value, what's really cool about this is that I already know what the y-intercept is. It's 0, of whatever our b value is. And so since I know it's 0, my b value is going to be 0. So therefore, my equation is y equals 3 halves x. And if you want to write plus 0, you are more than welcome to do that, but you really don't have to. This is the most simplified form of the equation. In letter B, we're going to do the same thing. I'm going to write m is equal to negative 8 minus 0 divided by 4 minus 0. That's negative 8 divided by 4, which is negative 2. And once again, I do know what the y-intercept is. This is 0, my b value. My b value, once again, is 0. So my equation is going to be y equals negative 2x. And what I want you guys to notice about these equations is that they have something in common. Although the slopes look very different, one is positive, one is negative, one's a fraction, one is not, both of them have in common the y-intercept of 0, 0. And more specifically, these are the types of equations that are direct variation. So you may or may not remember from Algebra 1 what a direct variation is, but that is something that you should have probably learned when you were in Algebra 1, and we're just going to review it in today's lesson. Our learning targets for today are for you to be able to say, I can write and graph a direct variation given an ordered pair, and I can write and evaluate a direct variation equation given a real-world problem in context. And I can determine if a table represents a direct variation as well. So a direct variation equation is the equation that is in the form of y is equal to a times x. This equation represents a direct variation between x and y. So some things I want you to note about it is that this is linear. It's in that form of y equals mx plus b. But more specifically, it's y is equal to a times x. And so because it's given a special name like direct variation, we don't use m as our slope. Instead, a is going to be equal to our slope. And more specifically, a has its own name. That a value, which is not allowed to be 0, so it's a non-zero constant a, has a special name, and that name is called a constant of variation. And in some of the problems that you will have, the question will ask you, what is the constant of variation? And more specifically, what it's asking you is, what is the slope? In your story problems as well, you might also see the language that y varies directly with x. Sometimes those variables might be other variables to represent specific context, but that language of varies directly with x is what you're going to see in story problems. So the thing that I really want you guys to know is that direct variation equations, that the graph of a direct variation equation in the form of y is equal to a times x is simply a line. That line has a slope of a and a y-intercept of 0 every single time. And the family of direct variation graphs consists of all of the lines that go through that origin, go through 0, 0. And it doesn't matter if the slope is positive or if the slope is negative. All of these equations that have a y equals a number times x are considered direct variation equations. And the equations that we had in our warm-up are also examples of direct variation equations. It will always cross through 0, 0 and some other points pertaining to an a value. That is our constant of variation. So let's go ahead and look at example number 1. In example number 1, we want to write and graph a direct variation equation that has -3, -9 as a solution. So just like we did up here in our warm-up, we're going to write our equation knowing that this graph has to cross through 0, 0 and -3, -9. So what I'm going to do is I'm going to identify my slope. My slope is going to be -9 minus 0 divided by -3 minus 0. That's -9 divided by -3, which I'm not going to call m. I'm actually going to call it a. And that's going to be equal to +3. So my equation is y equals 3x. But I want you to look at this. Consistently, over and over and over again, are you guys noticing that there's a shortcut? With all of these problems, do you guys see how it's really just the other ordered pair, not 0, 0, but the other ordered pair, y divided by x? Look at that, -9 divided by -3 gave us our answer for the a value. Look up here at our warm-up. 3 divided by 2 gave us our a value. -8 divided by 4 simplified to our a value. So there exists a shortcut when it comes to your a value. Since our a value is related to slope, and slope is the change in y over the change in x, simply put, a is equal to y over x. And this is a really cool shortcut that I want you to be aware of, because it will help you as we are working with story problems as well as with table values. So let's go ahead and graph this equation. And we use our normal ways that we've always graphed lines before. And that's where we start with our y-intercept of 0, 0. And I'm going to rise 3 and run 1 and come up with a few points along that line. I'm even going to plot -3, -9. And using whatever straight edge that you have available to you, whether you're using the side of a ruler or the side of a calculator, whatever, the side of a book, use a straight edge to draw this line. And so we have our equation and we have our line. And that is it. That's all you have to do for those types of problems. Let's look at example number 2. In example number 2, it says Hooke's law states that the distance d a spring stretches varies directly with force F that is applied to it. So what I want you to notice is that it has d varies directly with F. And it falls in line with that same language that we had up here, y varies directly with x. So in our equation, we can kind of view that d is in the y position and f is in the x position. Now, because these problems actually, or this problem has specific variables to represent real life information, I need you guys to not use, so do not use x and y in your problem. Instead, use D and F, but you can use that to help, or you can use X and Y as your guide to write your equation. So if we know that Y is equal to A times X represents a direct variation, we can replace the letter Y with the letter D. We would still have A as our constant of variation, and instead of the letter X, we're going to use the letter F. So this will help us with our structure for writing an equation. So in letter A, it says, suppose a spring stretches 15 inches when a force of 9 pounds is applied to it. Write an equation that relates D to F. So what I see here is that our distance that the spring stretches is 15 inches. And I see that that occurs when force is equal to 9 pounds. So what I'm going to do is I'm going to substitute 15 and 9 into my equation to help me to find A. So the first thing I'm going to do is I'm going to find my A value. And the way that I'm going to do that is I'm going to write D, which is 15, is equal to A times 9. I'm going to divide both sides by 9 so that I can get A alone, and therefore I find that A is equal to 15 over 9. But 15 over 9 can be simplified. If I divide both the numerator and the denominator by 3, I'm going to end up with A is equal to 5/3. So my equation is going to be D is equal to 5/3 F. And that is my direct variation equation that relates D and F. Now for letter B is I'm going to use this equation to predict the distance that the spring will stretch when a force of 6 pounds is applied to it. So that means I'm using this equation, D is equal to 5/3 F, and I am going to let F equal 6. So I'm going to write D is equal to 5/3 times 6. And if it helps you, you can make this 6 over 1 so that we end up with multiplying straight across. We end up with 30 divided by 3, which is equal to 10. And because this is distance and distance is in inches, our answer will be 10 inches. All right, let's go ahead and move on to the next page. For this next page, I have a pair question. Please be prepared to talk about this pair question next time I see you. And this is just another application of a story problem working with direct variation. So now what we're going to do is talk about tables. So because a direct variation equation, y equals a times x, can also be written as a equals y divided by x, that means that a set of data pairs, x, y, shows a direct variation if that ratio of y divided by x is constant. So if you see that every single time that you are checking your ordered pairs, it becomes constant, then that means that you have a direct variation. If you see that y divided by x is not the same number every time, then that means you do not have a direct variation. You have something else. So let's look at example number 3. In example number 3, it says the dimensions of 5 rectangles, each with an area of 24 square feet, are given in this chart. Show whether the length and width show a direct variation. And if so, we write an equation that relates the quantities. So what we want to do for these problems is we need to check every y divided by x to verify that it simplifies, or that each simplifies to the same number or the same value every time. If it does, then that means that we have ourselves a direct variation. If it doesn't, then that means that we don't have a direct variation. So let's go ahead and look at this table. So I'm going to check 24 divided by 1. That's my y divided by x. That is equal to 24. And now I'm going to check 12 divided by 2, and that's equal to 6. Unfortunately, in this problem, 24 is not equal to 6. And because of that, we have to conclude that this is not a direct variation. So therefore, there's nothing to talk about. I won't even check the other pair or the other fractions. As soon as you get something that is not true, you automatically know that it's not going to be a direct variation. I'm going to do letter B of the solo so that you can see how it works out. And then I would like you to complete A and C of the solo question and be ready to talk about that next time I see you. So in this solo question, it's asking you to analyze each table. And we need to identify whether one variable varies directly with the other. If there is a direct variation, identify the constant of variation and write a direct variation equation. Now, letter B, obviously I want to do this one because it's going to work out. So let's go ahead and analyze it. So what I see in this problem is I'm going to test every single y divided by x. And I'm going to go -9 divided by -5. And if you have just a basic old calculator with you, you can see what that value simplifies to be. 9 divided by, or -9 divided by -5 is going to equal 1.8. So now I'm going to check the next one. 1.8 divided by 1, that equals 1.8. 7.2 divided by 4. That equals 1.8. And 12.6 divided by 7? That also equals 1.8. You have to check every single ratio to show that it ends up working every time, because sometimes there might be one that is hidden that will not work. So because they all equal the same number, that number is our constant of variation. That's our A value. And so therefore, yes, this is a direct variation. With our constant of variation being 1.8, and our equation is going to be y equals 1.8 times x, or you can write it as that simplified fraction that we have up here of y equals 9/5 x. Now, preferably, I would like it as a fraction, just because if I ask you to graph these problems, it's a lot easier to use slope in that fraction form. But if I'm just asking for basic information, you're allowed to use a decimal. That is the end of today's lesson. If you have any questions over anything that I showed you today, please feel free to email me. Otherwise, I hope you have a wonderful day.